Hi, welcome back. The problem today is quite tricky problem. That is exponential equation pi power of x equal to x power of e plus 1. Now let's get started. We have pi power of x equal to x power of e plus 1, and x is the non-negative real numbers. It means x is greater or equal to 0. To solve this kind of problem, we have to use the method to prove the decreasing and increasing property of a function. In this case, we put the fx equal to pi power of x minus x power of e minus 1. Then the derivative of fx will be pi power of x multiply ln pi minus e multiplied by x power of e minus 1. Because we want to prove fx is the increasing function, then the derivative of fx have to be greater than 0. In this case, we need to prove this inequality. To prove this inequality, we assume that we have the equation pi power of x multiply ln pi equal to e multiplied by e x power of e minus 1. Then we just logarithm both sides of this equation. You will have x multiply ln pi square equal to ln e plus e minus 1 ln x. Then it would be 1 plus e minus 1 ln x. Then the next step is we put the gx equal to x multiply ln pi square minus 1 minus e minus 1 multiply ln x. Again, we find the derivative of gx. That would be ln pi square minus e power of 1 e minus 1 over x. Then from the table, you will see x at the point e minus 1 over ln pi square. This is 0 for the derivative of gx. And this is negative, this is positive, gx. And gx will be decreasing function and increasing function from this to this. And obviously, at this point, this is the minimum values of gx. So we have gx. The minimum of gx will be g of e minus 1 over ln pi square. And g of e minus 1 over ln square is greater than 0. Obviously, gx always greater than 0 with any x is greater or equal to 0. Then obviously, this function is impossible. If this function is impossible, this means pi power of x ln pi greater than e multiplied by x power of e minus 1. This means derivative of fx greater than 0 with any x greater or equal to 0. Then fx is increasing function. If fx is increasing function, so the minimum of fx would be equal to f0. Then if x0 equal to 0, because pi power of 0 minus 0 power of 8 minus 1 equal to 0. Obviously, fx always greater or equal than 0. Then finally, the root of this equation is x equal to 0. So that is the way to find the solution for this equation. So the lesson from this equation is sometimes you know that you have to prove the derivative of the function. The measure is always greater than 0. Then you can assume the equation like this. When you assume like this, you can apply another level of the derivative. Then the minimum of this always greater than 0. This means the derivative of fx at the original equation is greater than 0. Then you will see that the original function is the increasing function. That's all. Thanks for watching. See you later. Bye.